Okay. Hello, everybody. I'm Loren Shure, the first person hired at MathWorks. As such, in almost 35 years, I've contributed broadly to many of our products. I'm excited to be running master classes both this May and this upcoming October. My goal is to help you learn tips, tricks, and best practices so you can get the best out of MATLAB. I'll be covering today MATLAB and the kind of functions there are. For those of you who joined me 2 weeks ago, I talked about memory use in MATLAB. And actually, today I'm going to tie together the functions and the memory use as we go. And then in the fall, I'll be talking about programming with MATLAB and object-oriented programming. Please subscribe to the MATLAB YouTube channel to watch upcoming sessions live as well. Okay, so I'm going to be talking today about advanced programming techniques in MATLAB. And the main thing, I'll just go forward one slide for a moment to remind you what happened last time we talked about MATLAB and memory, and not everything about memory, but what you, as you're programming in MATLAB, would find useful to know. And so today I'm going to focus on the functions and all the different kinds of different functions there are, and I'm going to review them with you. And then I'm going to show you some examples of using nested functions. And as I said, then in the fall, we'll be talking about some other topics, including things like object-oriented programming. So let me go here. So functions, everything you wanted to know. So in this talk, I'm going to have slides that are going to support what I'm talking about, but I'm mostly going to use code. And please, if you have any questions, put them in the chat, and I will do my best to answer them. Okay, so a few years ago, we introduced a bunch of new function types into MATLAB, and I don't mean things like graphics or math or something like that. I mean them from a computer science point of view. But I'm also well aware that many of us, including me, aren't computer scientists. So what are these different kinds of functions, and how do they work, and why are they useful, and stuff like that? So I'm going to try to answer that set of questions today. So someone a while ago asked, there was these new function types introduced, and he wanted to know which ones were preferable from a speed standpoint. And he says functions in separate files. Subfunctions we now call local functions. And if you don't know what they are, that's okay. If you don't know what any of these are, it's okay, because that's the point of this talk. Inline functions is something very old in MATLAB. We no longer support them, and hopefully you don't use them. Anonymous functions and nested functions. And he wanted to know, other than scope, persistence, and program structure, what makes one work better with MATLAB than another. Well, I got to tell you first, I actually think program structure is invaluable in terms of a code base that I might come back to. If I'm doing a one-off, it kind of doesn't matter what I do. But if I need this to be robust and last for a long time, it matters not just what I program, but how I do it, so that it's easier to maintain and update and fix bugs if there are any, or something like that. So I think the extra things that he says there are important, but I get the point that he's interested about performance. Now, this got posted online back in the day when people used lots of news groups, and I was going to answer only to find out that Cleve, chief scientist at MathWorks and one of the founders, had answered. And I'm not going to leave this up long enough for you to hear it, except for you'll see he says something about an @ sign. So I want to tell you now how MATLAB works a little bit. Okay, so when you say something like y equals sine of x to MATLAB, what does MATLAB do? Well, the first thing, it sort of peels from the inside out. So it says x. What's x? And if x is in your workspace, it goes, aha, I know what x is, and it's ready to go. And so suppose x is in our workspace, and then it says sine. What's sine? And it says, is sine in my workspace? Now, you probably weren't expecting that, but that's what it does. Because if sine is in the workspace and x is in it, then we're indexing from x into sine. Well, that's not what most people probably mean when they write that expression. So suppose x sine is not in my workspace. And so it says, well, what type of data is included in x? It might be doubles. And then it says, do I know how to use sine on doubles? And the answer is yes. So, and if x had been instead a single, let's say, it would ask sine, what kind of sine? Does sine work on singles? And yes, it would. But if I said x equals a structure, does sign work on structures? Well, we didn't think that was a meaningful question because we don't know what's in a structure. It's arbitrary. And so there is no version of sign for structures. So unless you've made one specially somehow, you're going to get an error that there is no sign that's comparable or available for your variable x. Okay, now the reason it's so important to understand why MATLAB's doing and asking these questions is we often work on problems that require us, even though we're using MATLAB, to evaluate a function many, many different times, not one time with many values. We might do that too, but sometimes we have to do things iteratively. So for example, if you do numerical integration, if you do solve ODEs, ordinary differential equations, PDEs, partial differential equations, optimization problems, all of these have something in common. They are all operations that themselves are expecting one of the things that you need to give it is a function. They're going to optimize some function in maybe with some constraints. You're going to integrate some function between certain values and so on. And you're going to do solve an ODE with some initial conditions or boundary conditions. And so for all of those, when we're doing the solution, we do, let's suppose we're doing numerical integration. So what happens is we send the function in. It knows let's say it knows what function we want to integrate, and it's going to sample it at, say, if it's between 0 and 10, it's going to maybe say, 1, 3, 5, 7, 9. I don't know what it's going to do. Depends which method you use. And it's going to evaluate the points, and it's going to say, is this a good estimate? And it's probably going to say no at that point. And so it's going to go and refine and say, okay, now evaluate the function at these points. And then it's going to redo the integral estimation. And it's going to keep doing that until it gets within a certain amount of tolerance, whatever you've set or whatever the default is. And so no matter what we do, we're going to keep going back and calling that. Well, it used to be that when we did that in MATLAB and we have our y equals sine x, every time we called y equals sine x, we would not only ask what x is, but then we would look to find what sign went with it. Now what happens, and this is since our 2015B, is that, well, actually longer than that, but this is where a big change happened as well. What will happen is MATLAB will look to see what my first x is that I call it with. Let's say it's double, and it finds the version of sign. And then what it does is it basically caches that information. After it caches that information, you might be calling it again and again. And each time you call it, it doesn't need to ask that question. It says, do I know what kind of sign double takes? And the answer is yes. And so you just keep doing it. It's only when it gets no that it says, okay, let me go find that version. Finds, let's say, a single version, but then it keeps that in the cache too. So it doesn't have to keep looking up functions all the time. So that's why it's important to know how MATLAB works, because we can't avoid all those function calls, but what we can do is we can avoid calling them in a way that asks that question every time when we actually know the answer. So I'm going to do the next part sort of by a quiz, although it doesn't work as well on YouTube. So I'm going to answer the questions, but I'm going to lead you through what's going on. So I'm going to show you a bunch of different code, and it's going to cover anonymous functions, nested functions, function handles, regular functions, and local functions. And it's not going to include MEX files. It's not going to include models. It's not going to include data files. It's not going to include private functions, P code, anything else. It's something that can be written in the MATLAB language and exists in a file on your hard drive somewhere, on your MATLAB path. It doesn't even have to be on your hard drive, maybe. So I'm just going to shift my slides over so that you can see those. And I'm going to come over here and I'm going to make this just a little bit smaller at the moment. So those are the answers we're looking for. And now I have my very first function here. And so we have fquiz1. It has 3 inputs. It has 1 output. And you can see the calculation for the output. And this is a regular function. This is a simple function. In this case, there's nothing else in the file. And what you may not know and what might be useful to you is if you happen to be have programmed a bunch, but not in MATLAB, and you might find it weird that the function sort of dribbles off the end. We finish the statement. Doesn't look like the function's over. It is, but if I want to, I can terminate that function with an end statement, and you'll see the code analyzer is happy here. And if I go back, it's reevaluating it, and it's happy here now. So either way, so if you have old code that did not use end statements, you don't need to change it. If you want to make new code with end statements, that's okay. It's going to be on a file by file basis, and I'll be telling you more as it becomes relevant. But this is just a regular function. Okay. So now I'm going to come over here, and I'm going to evaluate this, and I don't even have to ask you what it is because MATLAB tells me here it's a function handle. Well, it's a function handle. So @ sign means function handle. That's and then how do I use it? Well, I use it like any other function. So for example, if I want to find out what sine of pi over 4 is, I can say fh of pi over 4, and we get 1 over square root of 2. And if I get sine of pi over fh of pi over 4 minus sine of pi over 4, you see I get exactly 0, even though the answer that I got here was floating point and had, in terms of looking like a double, it has a rough 16 digits that are accurate. But in its bit pattern, it has, 64 bits that represent it. The reason I get exactly 0 here, even though this is double precision, is because fh isn't sort of kind of sine, it's sine. Okay, and it's sine because I said I basically want to make a reference to the function sine here and assign it to a variable. And the reason we need to assign it to a variable is, remember, we're going to use it to pass a function to some other code. So here I'm going to call fplot with it. And if I call fplot with it, I can only pass variables basically, or even if they're temporary variables, I can only pass variables. I can't pass a function itself, but I can pass the proxy, the alias, the reference, or whatever for the function handle. And then in this case, it just makes my plot for me. Okay. So the next one I want to go over is this one. And I'm going to clear my workspace here so that you can just see the command window from a clean point of view. So now I'm going to say A equals 2, B equals 3. So on. So there's my fh, and now I'm going to call it because we can call function handle. So this fh is actually two things. So this would be a trick question if I were making you answer it. It's a function handle, but also if you try to name the function that is, it's not sine, it's not straight line, it's not slope and intercept or whatever. It's just some expression I made up. And I'm also telling you that it's a function of x. So that means it's going to use the values that it finds around at the time. In this case, it finds A equals 2, B equals 3. And that's why we get this answer now. So, and I can use this function handle, even though it's an anonymous function as well, in the same way that I could use the other function handle. So I could do an fplot. So I probably am doing that here. Yeah. So we can do that. It's pretty boring plot, but there you have it. Okay. And now here's an interesting question. So this was the expression I used. What if I said A equals 3 now, and then I said fh of 1 to 5? Well, if you ask me, we had 3 choices when we designed this. And I'm going to tell you all 3, and then I'm going to sort of have you think for a minute, and then I'll tell you what we did, what we chose. So I could have fh, just use the new value of A and evaluate that. I could have it use the old value of A if it's stored it away somehow and use that. Or I could error because I could notice that A has now changed since the time I created fh, and I could error. Well, what we decided that we wanted to do, well, before I just tell you what we decided, I'm going to show you what we did, and then I'll tell you why we decided what we decided. So am I going to get the same answer? I'd get the same answer if we reused the old value of A equals 2. And I get the old answer. So we don't pick up the new value, and I don't get an error. Now, if I want to use the new one, I can make a new function handle equals add of x, A times x plus b. Boy, I'm typing badly. Okay. And now if we look at fh and fh1, they look the same here. But let's see what fh1 does now. fh1, and we'll evaluate that from 1 to 5, and I get different answers. It's now embodying the fact that the 3 is part of the A value, not the 2 that I had earlier. Well, there's a terribly named function that's super useful here, and it's called functions. And I can do it, let's say, with FH1, and it will give me a structure back of information that's being held in my function handle. And you'll see it says, oh, my function, this is the function. It's anonymous. There's no file associated with it, and there is a workspace. So I can say s.workspace, and I'm using tab completion there. And then you'll notice it's in a cell array, and there's a struct in there. So I'm going to just look at this, the struct, and my struct is A equals 3, B equals 3. Now I could go through all this and I could change the A to something else, but it wouldn't go back and change FH1 in the same way when I changed A, it didn't change FH. If I want to change it, I have to reconstruct the function handle when I'm talking about anonymous functions. So what are these good for? These are good for a bunch of different things. One is that I get to sort of parameterize my function, and now I could do something like for A equals 1 to 30, FH equals out of X, A times X plus B, use the A there, and basically get a parameterized line with different slopes each time and do some simulation. But what I can also do is something that's really useful, and if you look inside any of the MATLAB source code, you may find us doing something similar there. Suppose I want to call my function integrate or integral, and it takes a function that is expecting only to be a function of X. But where's it going to get its A and B values from? Well, in this place, I'm showing you that FH gets them from A and B. But what if I had another function? Let me create another function handle, f of X, A, B equals at of, whoops, X and A and B. Notice that it now depends on 3 things, A times X plus B. And I can't just do this, F from 1 to 5 or 1 to 4, whatever, because it didn't get the parameters A and B sent in, because it's expecting them not from the workspace, but it's expecting them to be part of the function input. So I can call it instead, we can do X, and I can take my A, I can make it anything. I can go -1 and 3. And now I get some values out. But now I'm not in a good shape to call the integral function, which is expecting my function to be a function of X only. But I can say my fx equals f of X, A, and B, and we'll pass in X. But now I can hardwire in my A and my B. I'm not doing this right. It's at of X. It's a function of X. F of X, A, B. Whoops. X. And now I can put in my A and B either from the workspace, or I'll just put them in here, -1 and 3. So we get the same thing. And now I can turn my function call, which had 3 inputs, into a function call of a single argument. And if I give it 1 to 4 now, I get the same answer as I got the other way. So it's a really nice way of transforming, mapping functions, input sequences, basically. So I can turn the signature from being 3 inputs to 1 input, where I basically hardwire in those other parameters for what I'm doing. So I'm going to stop for a second and just go over to my chat just to see if there's any questions yet for me. And it looks like you're hanging in there. Don't forget to put things in there. Okay, so I'm going to be finished with anonymous and function basic function handles with this. I'm going to go on to some of the other things like nested functions and local functions from now. Okay, so I still don't see any questions, so I'm going to go. I'm going to assume it's an okay thing. Okay, so now I'm going to show you some code. Here is a function, fquiz4. You'll notice that there's another function sitting in this file. And the question is this make line function, is it a local function or is it a nested function? And it is a local function. We've had these for a very long time, since around the time I joined MathWorks. And if you're one of the people that prefers to see functions terminated, I can put an end statement here. But notice if I put the end statement here and we look over the code analyzer, it's kind of grumpy now. And we can come look here. And I can also look over here. It's all telling me the same thing. Let me zoom in. A function might be missing, possibly matching. An end might be missing, possibly matching function. And that makes sense here. So now I can put my end here. And now this function is happy from a code analyzer point of view, and it's exactly identical to what I had with no ends. So the rule here is if you put one end and there's multiple functions in the file, you must put in ends for all the functions. So you have to terminate all or none with ends. Okay, so let's take a look at the code here now. I've got sort of, this looks like the other thing, A equals 3, B equals 5, but now I'm going to call makeLine with X and A and B. And here's makeLine with X and A and B, and it's just going to return the straight line, which is going to flow through here. Okay, fine. Now, right now, the way local functions work, this local function is only available inside fquiz4. And maybe that's what I intended, but maybe I realize after a while that it's much more useful, and I kind of want other people to get it, but I don't want to like copy it out and paste it into a new file and put something else on my MATLAB path. Maybe I just don't want to do that. I don't know why. Okay, so is there something else I can do? Well, here's a question for you about programming. Can you ever think of a time in a programming language where you can put something in, like a double as an input, but you can't get the same thing out as an output, a double? Well, I can put a function handle in as an input, so I can actually get a function out as an output as well. And for that, I'm going to show you fquiz4h. And so you'll see I have a second output here with the function handle, and I added a line of code, and we could go back and forth and try to compare these, but it's much easier if I come over here and I do fquiz4 and fquiz4h, and we'll do compare selected files and folders. And by the way, for any of you who are longtime users, that's been in MATLAB since 2004. But it used to be difficult to find it, and I think it's been a little bit easier now. Let me swap the sides of these. So this is my new code. This is my old code. No, you know what? Let me swap it back. My old code. So here's the original code, and you'll see I changed the name in here, and I also put a second output. And you have a key down here. Something's modified if it's purple. If it's light orange, it's deleted. And if it's inserted, we see the blue. And so I added this line, make line. Okay, so how can I use this to my advantage? So let me come over here. Let me clear the workspace just in case I didn't. Did I clear it? There's nothing there. That's good. Okay, so I can say y equals f quiz for f, and I can just do 1 to 3, and we get our answer. I can also call it with 2 outputs, and we can get a function handle out. I just call it fh because it's convenient. There's no rule that says you have to name it the same way as me. And I have a fh, and so I can say fh, and notice that I can't just call it with 1 to 3, because if you look at makeLine, it's expecting 3 inputs. So I could give it the A and B that's there, 3 and 5, but those are in the local workspace. But I can also, I now have the liberty, now that I've exported it, I can also use different values for A and B and export that. And in fact, if I don't actually care about the output Y, I could call this, well, let's call it like this. Let me find where I called it, like this. Go back. Yeah, okay. So let me go back to this. So we're going to call it like this. But remember I said I don't really want Y. So instead of it cluttering my workspace, I can go like this. It says, that means I want the second output. And it knows positionally. And now I get my function handle. And now I can start using it. So in this case, it maybe doesn't have that much value. But notice that it does at least let me take some function and let it be used elsewhere if I wanted to. In this case, I'm only using it at the command line, but I could take this function handle now and use it as an input to another function, and it would get access to that. Okay. Let me keep going. Oh, I don't need that. Okay, so we have, let me clear everything again. Now I have something else. I have function fquiz5, a equals 2, b equals 5, y equals make line of x. So it looks kind of like fquiz4 fh. And then I have function y equals make line, y equals a times x plus b. You'll notice some different variable names and things like that. And then I have end, end. Remember before I had a function and an end with a function and then an end. So I didn't have this situation, which is I have a function and an end, and slipped inside, I have another function with an end. So make line is a nested function. And there's 3 or 4 reasons why I know that's true here. And let me explain what it is, what that's going on. First of all, notice a couple things. Notice my A and B are variables here, but it's saying the scope of variable A spans multiple functions. So notice that make line doesn't actually use A and B as the input. It's getting them from the parent here, A and B, and it's able to use them. In fact, it's also able to change them, though we're not doing that in this case. Anything that's on the function signature line, like XX and YY, those are considered to be variables local to make line. So they're not available up in fquiz5 unless I just calculate it and put it as an output, but I wouldn't use the same name here if I wanted to share them. I would have to actually not use it as an output in order to share the variables. So right now, y and y are distinct variables, although if you remember from a few weeks ago, they could be sharing the same memory at the moment because they're exactly the same values. Okay, but I was explaining why this is a nested function. One is because it's got the function and end. One is because it's calculating something with A and B, but it doesn't get A and B as the input, but it's not, the code analyzer is happy, so there's no problem with the code. And then, so that's 2 reasons. The third reason I know is not only did it say that it was colored, but if I just look, I can see that the differently colored variable names clue me into the fact that they're being shared. So I don't have any extra inputs here. I have my function and end inside a function and end. I've got the colored variables. And you'll notice that we also indented this code. Now, you don't have to indent the code. The white space to MATLAB does not matter. But I had suggested way back when that it would be really useful for me from a structural point of view to see my nested functions indented. And if you don't like that, you can come to the home, you come to the preferences, and you can change that if you don't like the default. But this is the default behavior to indent nested functions in MATLAB. Okay, so I've made it nice. Now make line doesn't, when I was, if I'm doing my integral somehow with make line doesn't have to ask what A and B are because it has access to them now. So that's kind of nice. I took it from being basically a 3-input function to a 1-input function. And so that's kind of helpful. And I'm just going to take a moment here. And so a quick question. What conventions does MATLAB use when naming functions? When do you use a capital letter and when not? That's a great question. And another question is, are A and B global variables? Great questions. Very glad you asked. Let me start to answer. So our convention is that function names all begin lowercase. And we don't have any function names that begin with an uppercase that I'm aware of. Now, there might be something in a toolbox that I'm not aware of, but we basically, we do, square root, or FFT, or if there's something that's really long, or I can even show you name length max. But if there's something that's really long, let me see if I code compatibility. You'll notice that I have a code compatibility report. It's what's called camel cased. It starts low, it bumps up, it goes down, it bumps up at the next word and goes down. So we use either all lowercase or camel case for function names. And that leaves a lot of other places where we can have capitals, and often we use them for creating, and actually we do that with method names for object-oriented programming, even though I'm not talking about that today. So that we save the uppercase names for other things. You don't have to follow that convention, but that's our convention that we use. And A and B are not global. They are only available to these 2 functions. Now, if I export this function with a function handle, then the values of A and B come along, but they're still not global. Not just anyone can use them, only MakeLine can use them here. So it's kind of like a global variable, but it's not global. It's definitely confined to a particular context, and that makes things really nice. So let me show you this next example and explain what's going on. So now I have fquiz 6. And you see the only line of code in fquiz 6 itself is this line: return me a function handle to MakeLine. And here's my MakeLine. It's y equals MakeLine of x, y equals a times x plus b is getting a and b from the inputs of fquiz 6. So let me show you what's going on. Let's do f11 equals fquiz 6 of 1 and 1. And let me do f22 equals fquiz 6 of 2 comma 2. Okay, so they look the same at the command line. And let's see what happens if I do fh of 1 to 3. Oh, right. f11 of 1 to 3 and f22 of 1 to 3. And I get different answers because I have different values in them, which makes sense. Okay, so each function handle is keeping track of its own stuff. So basically what I've got here is a function generator, a parameterized function generator here. And so I can create a suite of them and then sweep through parameters. And this function handle doesn't mess with this one's, and this one doesn't mess with that one. And so they can coexist. Whereas if it were global, truly, one A and B would be overwriting the other A and B, and it wouldn't be context dependent. So let me know if that doesn't answer your question, and hopefully it does. Okay, so I've got this function generator here for creating parameterized functions, and I might want to be doing some Monte Carlo simulation, or I might want to be doing some parameter sweep, and so this lets me do it kind of easily. So question, can MakeLine be called directly? No, MakeLine cannot be called directly. If it's a nested function or a local function, the only thing that can be called directly from a function in a file, I'm not talking about object-oriented right now, but the only thing that can be called directly is the main function, the regular function that's at the top. I will get to the point of these, but nested functions are really very useful some of the time. Okay, so it does make the code a little bit nicer too, but more readable, but it's more than that. So let me come to the next problem that I want to show you and explain part of what's going on. So let me clear everything out again here. Let me close this. And this is the final short example I have, and then I'm going to do some richer examples to show off what's going on here. So here I have fquiz 7, and it's a function that's going to count. Okay, and you'll see we set the initial value. You see current count because of the color. It is going to be something we keep track of. It's going to be used inside my nested function, which I'm not showing you yet, I know. Okay, and so let me show you what's going on here. So suppose we're going to something that we haven't been able to do in a long time, maybe, but we're going to go to some maybe an outdoor fair, and there's tickets for kids and tickets for adults, and someone's keeping track of how many kids and how many adults go. So I might say I want to count the adults. So adults is going to be fquiz 7, and when we quiz 7, and when we start the day, there's no one admitted yet, and I'm going to do one for the kids too. Fquiz 7. So even though they look like they're the same exact thing and they start off with the same exact value, let's see what happens. So suppose we come along and an adult comes in. So we're going to say adults. We want to do something with the adults. Well, adults is, remember, the adults is this count function here, right? Which is the function handle for get counter. And so we're going to call get counter, but get counter doesn't take any inputs. And if I just go like this, I'm just going to see the function handle. I'm going to see the variable here. And so I call it like this. And now an adult goes in and the count goes up. And we call and we get maybe 3 adults come in. And now we have another adult come, and he or she is bringing a kid. And then we get another adult and 2 kids come in. And notice that the counters are going separately for kids and adults. So let's do that funny functions thing. Let's do functions of kids. Let me do SK equals S there. And S adult equals functions of adults. Okay, so now let's do sk.workspace, because I showed you about that before. And you'll see this is the kids workspace, and the initial value is 0, the current count is 3, and it knows the function it's calling, get counter. And now let's do the same thing for the adults. And you'll see, even though they're the same function they're pointing to, since they got initialized, even though it was with the same value, they're counting at their own rates. So the current count in one is 5, and then the other one, it is 3. So now it's time to look at the rest of the code. So this code, you can see it's a nested function that meets all those different criteria I mentioned. And one thing I didn't mention, and I meant to mention, when you have a nested function, you are obligated to terminate it with an end statement. And once you do, you're obligated to terminate every function in that file with an end statement. So that's why we have here. And if you have very many, and you can nest functions inside functions. So if I get something really complicated, often I'll do this as get counter, just so I can see. But MATLAB actually helps me, because you'll see when I click, it underlines it and shows me where it is. But I could do, main function here. Okay, so let's see what's going on. So when I call fquiz7, it just sets up the current count with the initial value, the 0 in this case, and then it just returns the function handles of this. Now this, remember I told you inputs and outputs are local. If they're local, they're not being shared at all. And so, but this is how I need to get the output out, because I need it with a local variable, because that's the only kind of variable I can use as output. So I take my current count, and I bump it up by 1. And then I set my current count equal to the count, so I can get that count to be seen outside. So it's pretty simple here. And in the link for the YouTube session here, there will be a link that there in the chat, rather, or in the top of it, there will be a link that has access for the slides and the code. When you download this code, play with this if you don't know about nested functions. I did that on and off when I was first learning about them for a few hours here, an hour here and there. And after a few hours, it became a tool that I understood and could use. It's not the only tool you use, just like you don't always use only your hammer or only the screwdriver. It's just one more tool. So again, I'm sure there's that person saying, you still haven't answered my question. What is this good for? And I'm going to get to that in just a moment. But before I get there, there's just a couple more slides I want to cover first too. And the first one is, this is actually a trick question, sort of regular functions, function handles, anonymous, local, and nested functions. Which of these can be combined in a single file? And the answer is all of them. And you may find files in some of our code that actually do take advantage and use all of them. It depends what we're doing and how complicated things are, and how recently we wrote it and all kinds of things. But there's no reason you can't combine them. Okay, I told you about the functions, and I have two applications that I'm going to show you now. One is when I solve an optimization problem where I might need to pass additional parameters. And one is I'm going to build a graphical user interface. Instead of through App Designer, I'm going to do it just through code and show you. And I will show you why both of these are kind of really good cases for working with the potentially nested functions. Okay, so let me come here. Let me close this, clear this out, and let me go into my folder. We want to come up, and I want to go into nested functions, and I'm going to first do optimization. And let me just open that up. And okay, so nested function, optimization. So there's a lot of posts or questions we get about how to pass additional parameters. So how do I include extra parameters to define an objective function? Here I have an example. X1 and X2 are basically X and Y if you want, and they're going to go from -10 to 10 in both X and Y, or maybe -5 and 5, whatever it is. We plotted it on -10 to 10. And here you see my objective function, x1 squared plus b times x1 times x2. plus c times x2 squared plus some other stuff. So I've got my regular parameters, and from an objective function point of view in optimization, I've got some non-smooth and stochastic parameters. I'm not going to actually worry about the E, the stochastic one. And let me bring up, I brought up the wrong thing. So let me bring up the local function. And here's my local function, and I'm going to show you what it looks like to run this. So I'm going to get my function value, my locations, and my function value. I'm going to get my local locations and my local function values, because I'm calling the local version, and I'm going to call optim local. Notice that it said that it was looking for me to have 5 inputs, but I didn't get an error here. And you see that while it was working, it actually plotted, it started up here and went back here, some order, I forget which order, and then came around here. And this is that absolute value of something minus something, whatever the line was there in my slide. I can show you here again, right there, absolute value of x1 minus x2. Now let me come back here. And so that's what we get. Okay, now let me show you the code and explain a little bit more about what's going on here. So you'll see, first of all, I put in a lot of help, and then I used if nargin is less than 5, so I can come here. Let's see what we have to say. In case you don't know about this, this is a handy dandy function because I basically was able to run it in a demo mode, if you will. So it tells you nargin, it gives you an example here. So it does, depending on nargin, whether it's 2 or 1 or 0, it does different things. And there's also C also here. So I can see what other functions there's a nargin check, a nargout check, and a varargin, and some parts of the doc that you might be interested in. And in this case, this is probably not that interesting, but when it got introduced into MATLAB. Okay, so nargin tells me the number of arguments that I called this function with. Well, I called it with 0. So it set up A equals 3, B equals 2, C equals 1, D equals 6, and that E stochastic version I made 0. And then I'm having my plotting go from the range from minus 10 to 10. That's in both X and Y. I give it a starting X naught point. And then I'm calling optim functions. And I'm saying, please call fminunc, an unconstrained minimizer. And I'm saying how to do it. And notice that I also wanted to do that plotting. And my output function is down in here. Okay. And so then I'm going to call fminunc with my objective function. Notice that my objective function has to pass in, because this is whatever function is going to have to pass in all those values, A, B, C, D, and E. And then I have my X naught, my starting point, and my options, and then I run it. And then here's my objective function. This is the same thing written in MATLAB that I had on the slide. And then here's my output function. And you'll see it does different things. If it's in the first state is in the initialized state, which is an optimization toolbox state, then I'm going to plot the main plot. And if I'm in the iteration state, I'm choosing to plot things with the round filled red markers. And then if when we have a short pause in there, just so you can sort of see what's going on. And then I finally, when I'm done, I plot the final value in a yellow star. Okay, but notice my plotting function, which is just plotting some X's and Y's, needs to know all my other parameters, A, B, C, D, and E. Okay, range I'll give you because we're plotting it from minus 10 to 10, minus 10 to 10, X and Y, or X1 and X2. But why all of this other stuff? And I'm going to just take a quick moment because I think there's a question. Can we say this count function is a random number generator? I'm going to answer that count question in just a moment. I don't think that's correct, but let me think about it. It's not a random number generator. Remember, I'm updating the value every time I call it. So it's not random at all. So I might be missing the point of what your question is, but it's not a random generator at all. There. Okay, so this is kind of nasty that I have to do this and pass all my A, B, C, D, and E's, all my values everywhere. And I have to plot it into my plot objective function, which I have around here. And so it's really nasty. You'll see we are using some anonymous functions, though, to transform the input here into something that's going to be called with X in range when we get the objective function out. Okay, so here's the real problem. This is the theory that got developed when people thought that the important thing to optimize was this function of A, B, C, D, and E, my special parameters here. But now someone's come along and they've developed a new, more detailed theory, and it no longer depends on A, B, C, D, and E. It depends on A, B, C, D, E, F, G, H, I, J, K, and L. Okay, so if I were going to come here and change the code, I have to change this. And I have to change my examples if I'm going to be fair. And I have to change the help here. And I have to change this. And I have to put in default values or do whatever and get some values there. And I probably have to change some of the settings here. And I also have to make sure I change the calling syntax, not from A, B, C, D, and E, but all the way to L. And so that's just in the main function here, the optim local. And then I have to change in my subfunction objective function, I have to change from ABC through E up to A through L, and I have to put the right formula in here. Fair enough, you have to put the right formula in, right? And then I have to change this from A to E to A through L, and I have to change this call from A through L. Well, instead of making you watch me do that, I've already done that, and I'm going to make them, I'm going to pretend we're doing that, but I'm going to solve the same problem, but I'm going to use nested functions instead. So here is my nested function version, and you see I have parameter values A, B, C, D, and E that are going to get passed along. And if nargen is less than 5, I set my values. And then you'll notice range and these A, B, C, D, and E are all going to be parameters that somehow are available from my main function. And now I don't have to have my output function, as I did over here, come up here. In fact, what I'm going to do now, I think what I'm going to do is this. We will look at the compare. Okay, and I want to swap sides here. So my local one, the one we've been looking at the most, is over here on the left, and you can see the things I would need to change here. And I had to change a little bit, not some of these details, some of that is white space, but my output function no longer needs to be this whole long expression. It just needs to be my output function. And then I need to call my minimize function, which is fmin_unc. And instead of calling it with add of x, another anonymous function with this, I just get to call it with my objective function, which depends on x, my x naught, and my options. And here's my function, and here's my f of da da da. Here's the objective function right itself. And I would, if I needed to, I could just add right here the A through L parameters, and I could add them in here. And I don't have to change any of these other things, even down here, because down here I now call my objective function without having any other extra inputs, and I have my range. So I basically separated out the plotting that we're going to do from the actual function, that evaluation and minimization that we're going to do. And so I can now, with impunity, not have to ever change this down here, my output function. If I want to update it to the new theory, I have to update my objective function itself, and I have to update my default values and the help and the calling input list. And that's all I have to do. And the question is, when I do that, do I even get the same answer? Well, we kind of hope so, right? So let me come here. Let me bring this one up. Let me make a new figure. And let me put it over here. And now let me come to optim nested. And then let's just come to the editor and just say run. And you can see that we get the same answer as we got before. I didn't actually calculate I should have done xn and fn, but they're exactly the same. So I didn't actually change my calculation, the actual numeric calculation, but I made my function much easier to understand and update going forward. So I'm hoping that helps answer the question earlier about what are these nested functions good for apart from readability. In this case, it's a huge maintainability benefit as well, because I'm keeping the parameters separate from the actual, like the plotting, the function parameters apart from the plotting. And so, and when I need to change the theory, I don't need to go down here now and ever change my output function again, unless I want to have it look different, but that's a different separate question. So keep some questions coming. And if the person who asked about the rand I and rand n can amplify a little bit and say a little bit more about what you were meaning, that would help me to answer it better than I probably answered it for you. Okay, so I'm just trying to get into the right folder now. Open those. And I don't want you to see all the code yet, and we'll clear everything out. So that was the unconstrained optimization. I was using a function from the optimization toolbox to do this, fminunc, for the unconstrained minimizer. Okay, this next application is building a graphical user interface. I'm going to try to visualize a volume. One of the reasons I wanted to visualize a volume is because volumes can be large and large amounts of data. And so I want to see what happens, because I kind of, not only do I want to make it easy to visualize what's inside, but I want to, if my data is really big, I want to make sure I'm not making lots of copies of it by doing something from a programming point of view that could be avoided. So let me come over here, and I'm going to do, this is a trick I use. It's not really a trick, but I'm going to do help on Volviz app. You'll notice I put an example there so that now I can just go like this. And that's another way to run an example here. So here is my Volviz app. And what you see here is I've got basically a volume, and I've got something on the right-hand wall, the back wall, the floor, and then I have something at the left-hand end, which corresponds to my minimum X. And I can now drag my slider through, and we can see what's going on inside the volume. So this is a toy. It's not, the best thing that you've ever seen, but it's kind of cool. And I want to show you how I did it. And if I were in a room with you, I'd actually make you guess how many lines of code you think it takes. So take a second there and see if you come up with a number of how many lines of code you think it took. I will tell you one thing. It took me 2 files. I'm using 2 files. I'm using something called the Volviz app, and I'm using something else called volume visualization. Okay, so let me actually take just a quick look at the top of volume visualization. So it takes XYZ V in, and it's going to compute something out. So let's do this. Let's say S equals, let me make a new figure. Park this over here too so that you can see it. And then let's say S equals volume visualization of X, Y, Z, and V. And I'm going to put a semicolon on because I don't want you to see what the output is yet. But notice what happens is I get sort of the same picture, except for I'm missing the slider and I'm missing that slice on the left-hand end. So I can't move anything. But let's see what S returned. S actually is a structure, and it returned 4 things to me: minimum and maximum X, and then a function handle to some function named add slice plane in volume visualization, and a delete last slice plane function also in volume visualization. So if I use those names correctly, it sounds like what I can do is something like this. I could say s dot add slice plane, and I have to tell it where to add it. So let's add it at 9.3. And then let me add one at pi. And let's do square root of 2. And then let's do a plain old integer. Okay, so now I've made a mess. But I notice that there's something called delete last slice plane. So s dot delete last slice plane. And now, since it's not going to take any inputs because it's somehow the last gives me the notion that there's a list somewhere, I need to call it with no inputs. So we'll delete 1, 2, 3, 4. I deleted them all. Do you dare me? You think I'll blow up MATLAB? SegV? Error? Hard error? No, it just works because it was super simple to protect myself or, in fact, another user from this. Now, so let's take a look at the magic of what's in volume visualization. Here it is. So I have got my data in. It's going to produce that structure out. I showed you that at the beginning. Now you'll see that there clearly must be nested functions in there because I've got these purple variable names, X, Y, Z, and V. Remember, X, Y, Z, and V could be a large amount of data. What's in our workspace right now? So they're not huge here. Ugh, I always mess this up. Let me come here, come like this. I don't really want to go quite that far. I want to see their size. And then let me bring this back. Not that much. Go to the end. And let's bring this one back. Okay, so each of these is 250,000 bytes. So in fact, that's not that huge in this case, but this is a small example with 25 by 50 by 25. So suppose we had something that was 10 or 20 times more dense, these numbers would go up a lot. Okay, so let's see what's going on. So first I make sure that I have a reference for an axis that's empty and a list of slice planes that are empty. And if you think about this, I'm constantly moving a YZ plane around, right? And so I'm going to make a canonical YZ plane for slicing through a slice there. So I'm just going to create it from minimum Y to maximum Y, from minimum Z to maximum Z, and that gives me my YZ slice. And then you'll notice I call init display, and there's my nested functions here. And if we get to the end of the nested functions, my final code was to take the function handle for the slice plane, add slice plane, delete last slice plane, and the minimum and maximum of my X and park them in there. So let's see what my nested functions look like. Here they are. First of all, I'm going to call init display, and then the nested functions are where the action is. So here's my init display. Let's do that first. It's saying if my axis is empty or if it's not somehow a valid handle, create an axis, hold on, and put those lines around the edge of my volume here. And then I'm calling regular MATLAB functions. I'm calling slice. And I'm saying in my h-axis, given my data X, Y, Z, and V, at the maximum of X, I want to and I want to make a slice at maximum X, that plane, and no Y and no Z. I want to make another slice at maximum Y and another one at maximum Z. So this is just regular MATLAB stuff. And okay, I understand the question, and I will get back to the other question in just a moment. Okay, so thank you for doing that. So what you'll see here is I'm making my slices. This was for the maximum X was the wall over at the right-hand side. Maximum Y is the wall at the back, and the minimum Z is the floor. So I made these three planes basically. And then I'm saying all three of these, make them all use the same interpolation method. And this is all handle graphics stuff, and use a particular color map. And so this whole thing, including some blank lines and including some comment lines, is 62 lines long. Okay, but notice that that I never, because I'm sharing X, Y, Z, and V, I never make extra copies of that those variables, which might be quite large. As I said, they're not large right now, but they could be. So let's look at volviz now. And volviz does a little bit more. It says it makes a figure, and then it calls my volume visualization. And you might like my volume visualization. Maybe this is just exactly what you need, but you don't like what I've done with this slider. In fact, maybe you want to slide along a different direction. Maybe you want to make a movie. Well, you don't have to you can still use my underlying volume visualization as the sort of graphical engine there, and the add slice and delete slice. But you can put it together in a different way. Here's how I'm putting it together. So I'm making a figure. I'm calling the volume visualization, and then I'm adding one slice at the minimum. So that's one slice over here at the minimum X. And then I add that user control, and you can see this is just I'm saying I want it to be a slider. Its minimum value is the minimum of from my shared structure. The maximum value, place it at the minimum location. And when I get done, whenever it moves, whenever there's something, the callback is update slider position. Here's update slider position, and it says delete the last slice plane. So here's the slice plane, get the new location and put one in. So all we're doing with that slider is delete, move, add, delete, move, add, delete, move, add. Maybe you want to do a movie, so you don't want this to be the update. Maybe you want it to be something totally different. Maybe it'll be the rate of speed at which you play a movie that you create. So that's that. And this is 30 lines of code. So in under 100 lines of code, and by the way, you might count it less because this is one line effectively, but it's over many physical lines because of the ... And I still had room for help and some comments. But let me come back to the original one because I didn't show you all the functions in there. So I showed you the init display though. Let's look at add slice plane. So XD equals, I'm just going to create my X values for that YZ slice at the particular location where they are. First of all, I'm going to create the same size array, but I'm going to pick the X location because that's where we're going to put the slice. And then I create one new slice plane, and I add that new slice plane onto my list of slice planes. And then I just make the handle graphics look nicer. When I go to delete, let's ignore the if statement first. I delete the slice plane, and that basically takes it out of my figure window. And then I update my list of slice planes, and I could do it either of these two ways. And I basically take it off my list. And then now let's look at the if statement. If my list of slice planes is 0, in other words, I don't have any there, I just don't do anything. So I can't get in trouble this way. So the really nice thing is if you look at this, the volume vis thing, so it's going to take X, Y, Z, and V. It's going to call my volume visualizer, but it's not changing X, Y, Z, and V in here. It doesn't know if volume visualizer is going to change it. But it turns out if you go into volume visualizer, it's not changing it anywhere here. If you look through, you see it's not changed. So even though I have all these functions getting access to all these data and the data is getting passed around, notice how I'm basically exporting two function handles from volume visualization to be used inside VolVis app. And if I wanted to create a different app, I would still call volume visualization. I would probably still use the delete last slice plane and add slice plane, but I'd be using them in a different way. So hopefully you can see that I'm being careful because of using the nested functions of not having extra copies of the data around when I don't need to have it. MATLAB will manage all that for me because in the nested workspace, this isn't a copy of the data that's up here. It is that same chunk of data. They share it. When you're in the nested context, it can see and change and use any of the stuff in the enclosing workspace. And it carries around that information that it can use even when it gets exported and used inside another function. So I'm going to just quickly see what questions we have. So, okay, so let me come back for just a moment here. Let me say I want to open oh, conveniently doesn't have that. So let me open one of these. It doesn't matter which one. Just using this to get over there. Now let me come to FQuiz 7. Come on. FQuiz 7. Okay, so the question was, am I changing things randomly? I'm not changing them randomly. When I call, when get counter gets called, when I called kids, let's say, kids is a function, a reference to get counter. So it's going to call get counter. It's going to use whatever was the current count it had. Let's say, I think when we left it, it had 3, and it's going to come in here and it's going to say, take 3, add 1, make it 4. That's actually stored as 4 up here now, and then take that 4 and copy it as my output, and my new output would be 4. So there's nothing random about this. It's happening when I said for it to happen. So it's basically doing, I mean, it is doing A equals A plus 1 because that's what I programmed in it. So hopefully now that you see the code again, that will help you there. And I want you all to be thinking about your final questions, because I've got a couple more slides here. Why use nested and anonymous functions? Oh dear, I don't want all these things. Okay. Why use nested and anonymous functions? Well, they end up being pretty useful from the point of view of the nested functions, and also the local functions don't add anything to your MATLAB path, so it doesn't basically bog down and possibly shadow other functions. So if you want to call something inside your function with a nested function, a name that you've used elsewhere, but it will use your current one that's in your current context, that's okay. If it's the right name to use, you can use it. So you get fewer problems with name clashes when you do that sort of thing. I also talked about the memory savings, since there was only one volume being spread all around and we were never changing it. And they were always using even if we were changing it, was still only ever using the original data that I put in. It will only make it's only one copy. I'm not making copies of it every time I call other functions. So it ends up, the combination of nested functions and large data work very well, because you make sure the large data is sitting in the parent. And then all of the different nested functions that can see the data in the parent are changing the one and only copy of that data set. And so it can be a very effective way to share information there. It also gives you pretty nice program structure that you could see. I mentioned that you can call these nested functions, or these functions with no inputs, with you have to call them with open and close parens. And some of these things are just advice that I've been giving you all along. So there's a bunch of different resources available. I happen to write a blog for MathWorks, and you will, if you go there, you will see a category that I keep called function handles, and you'll see a bunch of posts that I've made over the years on that. And you'll see a bunch of information in the documentation and examples there, and available there. So I'm just going to summarize. I didn't summarize today what the MATLAB memory usage was. That was from 2 weeks ago. But today we talked about nested and anonymous functions mostly. And I did talk about local functions too, but they're very good at encapsulating data and keeping the data in the context that you need to be using it in. They're efficient for sharing memory between functions, and they give you another choice for the name and variable scopes of things. So that ends up being very helpful in terms of managing names, so that you don't get clashes. And since you're not putting extra stuff necessarily on your MATLAB path, you get less clutter there as well. And with that, I am done. Please finish up your questions and send them on, and I will try to answer them before we finish up. Thanks a lot for attending. It doesn't look like it. Well, we can end it then. Yep. Thank you so much. I just want to remind you one last time that we have the last session already on YouTube. This one will show up there in just a few minutes. Those were both on advanced programming techniques. In the fall, I'll be coming back in October to talk about programming with MATLAB and tools that help you from a programming point of view. And I'll also have a session on object-oriented programming. If you're interested in these, please sign up and subscribe to the MATLAB YouTube channel so that you'll get notifications so you can watch them live. Thank you.